Today we are going to do the notes for lesson 4-7, and those notes began on 245, page 245. Absolute value and distance. I can use coordinate and absolute value to find the distance between points with the same x or the same y coordinates. Starting at learn, find horizontal distance. You can find the horizontal distance between 2 points with the same y coordinates on the coordinate plane by using coordinates and absolute value. When 2 points are in the same quadrant, they have the same y coordinate. Subtract the absolute values of the x coordinate to find the distance between the 2 points. So at this point, consider -5. So we went over 5, -5, down negative to -4. So we have one point here, -5, -4. And we also have a second point here. We went over 1, so -1, down -4 to -4. So we have -5 and -4. And as you can see, the second numbers, the y coordinates, are the same, -4 and -4. But the first ones, x coordinates, the first coordinates are the x coordinates. We have -5 and -1. Consider these points, -5, -4, and -1, -4. They have the same y coordinates, so find the absolute value of each x coordinate. So remember, the absolute value is how far is it from 0. So -1, we have an absolute value of -1, and the absolute value would be 1. Our absolute value of -5 would be 5. It would be -1 because it's 1 unit away from 0. It would be -5 would be an absolute value of 5 because it's 5 units away from 0. And then we take those two absolute values and we subtract them. 5 minus 1, and we have a distance of 4 units between the 2 points. So we would count 1, 2, 3, 4. That's another way to look at it, is we can do the subtraction or we can do the count. If both points are in quadrant 3, will the distance be a negative number? Explain why or why not. And if we take a look at this, the distance here, because we're using absolute value, the distance will not be negative. It will not be negative because it cannot be. We are looking at how far away are those 2 points. And because we're using the absolute value of those 2 points, we cannot use it will not be a negative number. Carrying on to page 246 at the top. When 2 points are in different quadrants and they have the same x coordinate, add the absolute values of the x coordinates to find the distance between the 2 points. So consider these points. We have a -4, +2, that's 1 point. We have a +1 and a +2. So as you can see, these 2 points are in 2 different quadrants, but they have the same y coordinates, 2 and 2. So consider these points. They have the same y coordinates, so find the absolute value of the x coordinates. So that would be the first number. So the absolute value of -4 is 4. It means it's 4 units away from 0. The absolute value of 1 is 1 because it's 1 unit away from 0. Then what we do is we add these absolute values together. 4 plus 1 would equal 5. So the distance between the 2 points is 5. And if I go up here, I can take and I can say here's 1 unit, 2 units, 3 units, 4 units, 5 units away. Carrying on to example number 1. Find the horizontal distance in the same quadrant. So in the same quadrant, remember, we have to subtract the absolute values. So same coordinates, subtract. So they both begin with an S. That's how I remember it. And if they're 2 different coordinates, like we just had right above here, if they're different, we need to add them together. Different and add. Add has D's in it. Different is D. So find the coordinates between the 2 points. So I'm going to look here, find the horizontal distance between the 2 points. Consider the scale on each axis. The scale of the axes is a half a unit increments. So I have 1/2, 1, 1.5, 2. This would be -1/2, -1. This is +1/2. If I'm going below, it would be -1/2, -1, -1.5, -2. So I'm going to look at these two coordinates. So I have U and I have Y. So it says identify the order pairs for each point. So for U, I am going to say that I need to go over a half. So it's +1/2. And I'm going below 0. So I have 1/2, -1/2, -1, -1.5. So -1.5. So U would be +1/2, -1.5. And then V, I would have to go over 1.5, 1.5. I went over 2 spaces, 2, and that is positive. And then I would go down -1.5, -1, -1.5. It has the same y coordinate as U. These have the same y coordinate. So since the y coordinates are the same, find the absolute value of each coordinate. So the absolute value of 1/2 is a half. Absolute value of 2 is 2. Because these y coordinates are the same, we don't have to deal with those right now. What we're doing is finding the absolute value of the x coordinates. Because the coordinates are in the same quadrant, we subtract. So same, subtract. So we would take 2 minus 1/2, and we would find that U and V are 1.5 units apart. So if I count over, it's 1/2, 1, 1.5 units. Check. Find the horizontal distance between these 2 points, P and Q. So P is, if I take a look at this, it would be -1, -2, -3, -4, -5 is the x. And then I go -1, -2 would be the y. And then Q, so I'm going to go over -1, -2 is the x coordinate. And then I'm going to go down -1, -2. -2 would be the y coordinate. And as you can see, the y coordinates are the same. So we would find the absolute value of -5, which is 5, the absolute value of -2, which is 2. And then because they're in the same quadrant, we would do 5 minus 2, and that would say they're 3 units apart from each other. And if I go back to P and count over to 2, I have 1 unit, 2 units, 3 units. So 3 units apart. Carrying on to page 247 at the top. Example 2. Example 2, find horizontal distance in different quadrants. So now, if they're the same, we subtract. If we are finding in the different quadrants, then we add. Different, add. So find the horizontal distance. So I have E and F. So to find the horizontal distance between the 2 points, consider the scale. The scale of these axes are 25 hundredths unit increments. So each line is 25 hundredths, 1/2, 75 hundredths, 1. So E, we would go over 25 hundredths, half, 75. So it would be -0.75 for E's. And then we would go down 1 unit, and remember units are 25 hundredths, so -0.25. Then F, we would go to positive over 1 unit, which is 0.25, and down 1 unit, which is -0.25. So if I take a look at those, I find that the y coordinates are the same, so we don't have to worry about those, but the x coordinates are different. We have a negative, we have a positive. So for E, negative 75 hundredths, the absolute value would be 75 hundredths. And for F, the absolute value of 25 hundredths is 25 hundredths. So at that point in time, we know that we have to add the absolute values together because they're in different quadrants. And U and V are 1 unit apart. And if we take a look and we go back up here to the picture, we can say here's a 25 hundredths, 1/2, 75 hundredths, 1 whole unit. Check. Find the horizontal distance between the 2 points. So we have point K and point L. So point K, we would say we go over -1, -2, so it's a -2, and we go vertically 1. So the coordinates for K would be -2, 1. The coordinates for L, we go over 1 unit, so it's a +1. We go up 1 unit, it's a +1. So for L, it's +1, +1. And if we can take a look, these y coordinates are the same, and the points are in 2 different quadrants. So we need to find the absolute value of -2, absolute value of 1, and the absolute value of -2 is 2. The absolute value of 1 is 1. And because they're in different quadrants, we have to add them together. So 2 plus 1 equals 3. So they're 3 units apart. I can go back and I can say here's 1 unit, 2 units, 3 units apart. I'm going on to page 248. Now we're going to look at, so those were horizontal distances. Now we're going to look at vertical distances. You can find the vertical distance between 2 points on the coordinate plane with the same x coordinates. So again, we're going to have the same x coordinates, but different y coordinates. So we're using the same process as we did before. So when the 2 coordinates are in the same quadrant, they have the same x coordinates, subtract. So again, we're looking at same and subtract. So here we go. We have a 3, -1 point. We have a 3, -5 point. So the 3's are the same. And we have to look at the y coordinate. So -1, the absolute value would be 1. Absolute value of -5 is 5. We would subtract them. 5 minus 1 is 4. So the distance between these 2 points is 4 units. And we can count. Here's 1 unit, 2 units, 3 units, 4 units. Going down to the next part of the page. When 2 points are in different quadrants, we have to add them, just like what we did in the previous one when we were checking horizontal distance. So consider 2, 1. So I'm going to go over 2, up 1, and over 2, down 4. So 2, -4. You can see that the first numbers are the same. So we're looking at the y coordinate, the vertical distance between 1 and -4. So we look at the absolute value. So the absolute value of -4 is 4. Absolute value of 1 is 1. And remember, we have to add them this time when they're in different quadrants. So 4 plus 1 is 5. The distance between these 2 points is 5 units. So we would have 1 unit, 2 units, 3 units, 4 units, 5 units. Going on to page 249 at the top, example 3. Find the distance in the same quadrant. So again, we're going to use the same process. So find the distance for point D, which is -1, -1/2, and C, -1, -2. So the x coordinates are negative and the y coordinates are negative. That means the quadrants are in which quadrant? These points are in quadrant 3. The x coordinates are the same. So we have -1, we have -1. So they're the same. We don't have to worry about those. To find the distance, each point is from the x-axis. Find the absolute value of the y. So we need to find the absolute value of -2 and the absolute value of -1/2. So the absolute value of negative 2 is 2. The absolute value of negative 1/2 is 1/2. And because they're in the same quadrant, we subtract. So 2 minus 1/2 gives us 1.5 units apart. And we could do that even without the picture. So here's the check. Point A is negative 1/3 and negative 2/3. Part B is negative 1/3 and negative 1/3. So I need to take a look, and I can see that the first numbers, the x coordinates, are the same. So I don't need to do anything with those. But I do need to find the absolute value of the second numbers, the y coordinates. So the absolute value of negative 1 1/3 and the absolute value of negative 2/3. So the absolute value of negative 1 1/3 is 1 1/3. Absolute value of negative 2/3 would be 2/3. So because they are in the same, if they're in the same, remember, if they're in the same, you have to subtract. So I'm going to take 1 1/3 minus 2/3. Now, if I take a look at this, I can say, okay, I can change this. 3 times 1 is 3 plus 1, so it would be 4/3 minus 2/3. And 4/3 minus 2/3 would be 2/3 of a unit. Carrying on to page 250, example 4. Find vertical distance in different quadrants. So remember, different quadrants, we need to add them together. So find the vertical distance between point S, 1 and 1 coordinates would be 1 and 1/2, and t would be 1 and negative 1/2. So as I can see, the first numbers, the x-axes are the same. I'm looking at the second ones. And remember, the x ones are the same, the y ones are different. And if they're different, that means they're in different quadrants. So the x coordinate are the same. To find the distance, each point is from x coordinate, find the absolute value of the y. So the absolute value of 1/2 is 1/2 or 5/10. The absolute value of negative 5/10 would be 5/10. And because they're in different quadrants, we have to add. Remember, distance different, add d different, add d. So 1/2 plus 1/2 or 5/10 plus 5/10 is 1. So they are 1 unit apart. So let's do this one now. The vertical distance between E, which is 5/10 and 1.5, distance between, and then F point is 1/2 and negative 2. So the first ones are the same. So we do not need to worry about those, but we need to look at these second numbers. We need to find the absolute value of 1.5 and the absolute value of negative 2. So the absolute value of 1.5 or 1 and 5/10 is 1 and 5/10. And the absolute value of negative 2 is 2. And because they are one positive, one negative, we need to know that they are different, so we need to add them together. So we would take the 1 and 5/10, add it to the 2, and we would come up with the answer of 3 and 5/10 units apart. 3 and 5/10 units apart. Going on to page 251. This is actually an apply page, and this is where I'm going to stop that we can do this in class.